Okay, so for section 4 of unit 2, what I want you to be able to do is describe solutes, solvents, and suspensions, and explain the difference between acids and bases. Um, so when one substance is dissolved in another, it's called a solution. So think about in the refectory the drinks that you get, like citrus peach and things like that. That's a solution, right? It's mixing water and concentrated sugar, basically, and those two things are mixing together, and that's a solution, right? So you're drinking a solution every time. Same thing with chocolate milk. Um, but every solution has two parts. It has the solute, which is the substance being dissolved in the liquid. So it's the concentrated sugar or the powder, whatever it is. And then it has the solvent, which is doing the dissolving. And that word is in solvent: dissolve, solve. So substance doing the dissolving. And this is usually a liquid that's doing the dissolving. In most cases, it's water. So in this case, you have lemonade powder, which is the solute, and water is the solvent. And this is called a solution, right? This lemonade solution. Water's polarity, the positive and negative ends of water, oxygen being the negative side and hydrogen being the positive side, allow it to dissolve many types of solutes by basically pulling them apart, including salts, minerals, and gases. Salt water is the most common, probably, solution that you see examples of. So you take water, which is the solvent, and then you take salt, which is the solute. You put the salt in, and water dissolves it, and it becomes a saltwater solution. Water is often called the universal solvent because it's the best at what it does, and some particles cannot be dissolved in water but can be suspended. So, like rocks, soil, sediment, things like that can't be dissolved, and they'll just be carried by water. They're suspended in the water until they're deposited further downstream in the case of a river. Water molecules can be separated into hydrogen ions and hydroxide ions, which are charged particles when they are in a solution. And they can also combine back into H2O, so very versatile. So here's the chemical formula for that. So what we see here is H2O, which is a um, molecular compound, and then you have hydrogen ions and the hydroxide ions. And so, how does water separate into hydrogen hydroxide ions? So, while there are two hydrogens, right? Hold on, my annotation tools are not working. So there are two hydrogens and there's one oxygen. So when this dissociates, it becomes one hydrogen ion that's positive, and one oxygen which with a hydrogen, which is hydroxide, that's negative. Okay, and then it can also go back the other way. So the arrows in both directions means that this reaction can take place in both directions. So because H2O forms an equal amount of hydrogen and hydroxide ions, it is considered to be a neutral solution. So one hydrogen, one hydroxide are formed from water. So that water is neutral, right? So this is why on the pH chart that you've probably seen, water is neutral because it's a 1-to-1. 1-to-1, they cancel each other out, positive and negative, right? It is a neutral solution, okay? So if there are more, so the pH chart, right? We've seen, let me get text here, sorry. pH is, what that means is product of hydrogen or proportion of hydrogen. And so if there are more hydrogens than there are oxygens, it's going to be more acidic. And if there are more hydroxides than there are hydrogens, it's going to be more basic or alkaline. Okay, so pH stands for proportion of hydrogen, right? So the amount of hydrogens, if there are more, it's acidic. If there are fewer, it's alkaline. And so that's where we get our pH chart. So acids and bases, how do they differ? So like I said, an acid is a substance that forms higher concentration of hydrogen ions in solution than water does. So water is not acidic because it has one hydrogen to one um, hydroxide. But some substances are acidic because they have more hydrogens than they have hydroxide, right? So an example of an acid might be like lemon juice. A base or something that is alkaline is a substance that forms lower hydrogen ions, which means that they have more hydroxide ions, a higher concentration. So that would be something like bleach. And here's a chart. You may have seen something like this before. We give water, which is neutral, the number 7. Um, so that's a 1-to-1 solution. So each step on the pH scale is a factor of 10. So, for example, a pH of 5 has 10 times more hydrogen ions than a pH of 6. And so a pH of 4 has 100 times more hydrogen ions than a pH of 6 because it's 10 times 10. Okay, so that's how that works. So a solution with a pH of less than 7 is called an acid. A solution with a pH of more than 7 is called a base, or it's more alkaline. pH of 7 is neutral. Here's some examples below. So some characteristics of each, you need to know this. Acids taste sour. They neutralize bases because they're the opposite. So if you add an acid to a base, it'll neutralize as long as the proportion is similar on either end. Acids corrode metals, have a pH of less than 7, and have a higher concentration of hydrogen ions. Bases are slippery. Think soap. Soap is very basic. They neutralize acids, so the opposite of what an acid does. They're also known as alkaline, have a pH higher than 7, and have a high concentration of hydroxide ions. So water is a universal solvent because many substances dissolve in it. It can also dissociate into hydrogen and hydroxide ions equally, so it's neutral and has a pH of 7. And acids and bases are not neutral, so acids have a higher concentration of hydrogen ions, while bases have a higher concentration of hydroxide ions.